Good afternoon, everyone. Hope you're having an awesome Chain React. I really appreciate all of you being here for my presentation, Stability First, Building React Native Apps that Scale. My name is Targosz. I am a principal software engineer at Clearcover, where we have been using React Native for the past 7 years. Clearcover is a digital-first car insurance agency, and our mobile app is a critical part of our business. It's where our users go to perform an array of tasks, including making payments, filing claims, performing policy changes, and more. Clearcover is headquartered in Chicago, and I am a proud Chicago native. Oh, I love this. Oh, perfect. OK, so the amazing staff at Infinite Red asked that I don't get political while I'm on stage, but now that I have the stage, I'm gonna make my opinions known. Deep dish pizza is not Chicago pizza. Thin crust, tavern style, square cuts of pizza is true Chicago pizza. I love you guys. Thank you so much. But it begs the question, where does this disdain, this anger come from for deep dish pizza? Deep dish pizza is sloppy. It's messy. It's casserole. I'm trying to eat it. It's falling over itself. It's just not stable. I'm so glad I got to put a pizza joke in. Stability should be a forethought. We all know how great it is to be able to build apps rapidly with React Native. It's one of the best parts of the framework. But we can't let rapid development get in the way of a stable app experience. When you think about it, stability is an expectation, not a feature. Users will never rave about stability, but they will complain about it. You're never going to hear someone say that the latest app they use is boring and doesn't offer much, but it never crashes, at least. On the other hand, even when an app they're using provides them value, if it's constantly breaking on them, they'll understandably not want anything to do about it. Stability is something that users only think about when their apps are crashing. Do you think anyone outside of the tech industry knew what CrowdStrike was before today? Even Ken was talking about it. So you know that it's a big deal. As one of the many great quotes from Futurama goes, when you do things right, people won't be sure you've done anything at all. So let's quantify what doing things right is. So here we have a table denoting different levels of stability and their respective crash rates. And you'll see that I have this gold standard of 5 nines, or 1 crash per 100,000 users. This is a fantastic goal to achieve, and it's indicative of an extremely stable app. Of course, we want to shoot for the stars, but it's OK to be realistic. A great goal is in between the 4 and the 5 nines, or somewhere in between the range of a crash per every 1 in 10,000 to 1 in 100,000 sessions. It's a nice balance of being obtainable while still showing a strong commitment to stability. Before we go any further, I want to show what our stability rate at Clearcover is. If I'm going to stand up here for 30 minutes and explain the ins and outs of building a stable app to you, I want to be transparent about what stability looks like for us. You can see we're at a crash-free session rate of 99.997%, or roughly a crash for every 33,000 sessions. This puts us right in between those 4 and 5 nines that I was talking about. And as a note, this stability isn't due to a lack of features. As mentioned before, we have a wide variety of actions that users could take in the app, and many that dive into the native layer. Taking pictures, recording videos, getting and displaying a user's geolocation, and more. We're very proud of our stability rate, and we're always looking to improve it to provide the best experience possible to our customers, and I want to help you all achieve the same in your apps. So, what are the problems that come from overlooking stability? A recent analysis shows that 62% of people uninstall an app if they experience mobile crashes. It can seem kind of aggressive, but if you've ever been using an app and you're multiple screens into a lengthy flow, requiring a lot of data, and then the app bugs out on you, you have to reopen it, and all your progress is saved, I get really, really annoyed. And it's not just the users affected, it's developers too. It's incredibly frustrating when you're in the middle of a sprint, up against timelines, and a new production issue pops up that you now need to investigate, fix, and test. And finally, from a business perspective, it leads to a very negative spiral. You have these crashes leading to a negative user experience, negative reviews and uninstalls, and a decreased user base and decreased downloads. So now I want to look at stability in a React Native context. All the numbers here come from an analysis conducted by Bugsnag, a performance monitoring tool, and the results are shocking. On the right-hand side, we see the stability score for native Android, native iOS, and React Native apps at different percentiles. And when looking at the median stability score, this analysis found that React Native apps are more than twice as likely to crash than their native counterparts. With this median React Native stability score, it's about 1 in every 167 sessions crashing. But what's terrifying is that 25th percentile, 97.83%. Thinking back to our table from before, I didn't even include a 1.9 as an option. That's 1 in every 46 sessions crashing. If we took that 25th percentile and applied it to this audience of, say, 200 here, that would almost be 5 people crashing during the presentation. Now, depending on your interest in this talk, you might think that's like not a bad thing, but for the purposes of this analogy, we're saying that's a negative experience. So this begs the question, why are React Native apps less stable than their native counterparts? And to start off, I want to make something clear. React Native is very stable. The days of a new major version being released every few weeks with breaking changes are well in the past. The framework is good. So if it's not the framework, it means it's how it's implemented. I have 2 categories here. Challenges that are specific to React Native and those that any mobile developer can run into. First, JavaScript not having static types leads to a lot of development headaches. Second, the vast amount of open source libraries means a lot of our app functionality is powered by code that we're not aware of. And finally, as a general mobile challenge, a lack of type safety between the front and the back end leads to a lot of stability woes. So let's see how we can solve these issues and make your app more stable. For our first topic, we're going to be talking about TypeScript. I know that there's differing opinions on TypeScript, and there's been some blog posts out there about big libraries not wanting to use TypeScript anymore. And to be candid, when I started at Clearcover 5.5 years ago, and it was my first jump into TypeScript, I hated it. I was thinking to myself, rather than dealing with squiggly lines and the compiler yelling at me constantly, what if I just built the feature like I was supposed to? But the more I worked with it and learned how versatile it is, the more I loved it. Fast forward today, and I would truthfully refuse to work on a project in vanilla JavaScript. I love TypeScript. I'm glad to see other of my bird friends up here. And if you don't want to listen to me, listen to the React Native team. As of version 71, React Native is now TypeScript by default, showing the React Native team's commitment to TypeScript now and continuing in the future. So let's see what TypeScript gives you. The most standard and powerful feature being static typing. We have a very simple example here of add numbers, which I'm pretty sure was on the Cisco Meraki slide. I didn't steal this, I promise. We see here in vanilla JavaScript, we're passing in 2 arguments, A and B, adding them together. And then we see here that we're passing in a number and a string. So it's going to work, and that it's not going to crash, but it's not going to give us the answer or the result that we're expecting. So we convert it to TypeScript, and we see, hey, we can't pass a string. It's not compatible. We need to be a number. Awesome. We solved it. We created an addition function. This is a pretty basic example, but I don't want to show 30 different snippets of TypeScript. So we'll get to a more impactful example. Once you have TypeScript implemented, you'll realize just how much it improves the developer experience for new and existing developers alike. We had an engineer join Clearcover a few years back, and he said that our code base was the easiest time he's ever had jumping into a project that he had never worked on before. He was coming from a JavaScript React Native project, and he said that TypeScript made such a difference for him. And I don't want to undermine any of the amazing engineers we have at Clearcover. We make great code, and we have great people working. But he specifically called out TypeScript, knowing what needed to be on what screen, what functions accepted what different values, and just being able to jump into something he had no idea what it was, but understanding what data needed to be there made his life so much easier. And it's not just new developers that benefit from this. As projects get bigger and bigger, there's more to keep track of. Having strong types throughout the code base makes jumping back into old features that much easier. Additionally, the vast majority of libraries are TypeScript first, making integration a lot simpler. On that note, here's an example from the wonderful React navigation library. On the left here, we're navigating to a screen, and on the right side here, you'll see the parameters that we require. We create a type for it. Of course, you don't have the context of what all of these different values and properties are, but that's part of the beauty of it. Just by having this type defined, you know exactly what has to be passed for the screen to work. There's no going back and forth between two files to know what's required, what's optional, what needs to be included alongside different enums. You know exactly what needs to be there to have it function. So to summarize why I could never go back from TypeScript. We have enough on our plates as engineers. I want to spend my time solving complex problems, not chasing down a reduce function that I forgot to return an accumulator in. I need the confidence that static typing gives me, because I know that as long as I don't have TypeScript issues, my program's going to function as expected. And finally, I love how much better my developer experience is with TypeScript. Having autocomplete and knowing that I'm safe from silly mistakes makes my life that much easier. As I mentioned at the start of the section, when I first started using TypeScript, I thought it was slowing me down. But very quickly, after adopting it and getting used to it, I realized it was a massive boost to my productivity. And finally, going back to that crash free rate that I showed at Clearcover, if I had to choose a singular thing that makes that possible, I'd say TypeScript without a second thought. So we addressed the lack of static type issues that JavaScript has. So let's now focus on the general mobile challenge of a lack of type safety between the front end and the back end. In this section, I'm going to show how validating data leads to an incredibly stable app. So I know I just sang my praises for TypeScript, but it can only do so much. So long as the data that you're working with is built completely within your app, you're fine. But as soon as you introduce data from external sources, you don't have that guarantee. And let's be honest, in the world of mobile, you're working with mainly data from external sources. A rule that we always follow at Clearcover is you cannot implicitly trust the structure of data from an external source, whether that be your own microservice or a third-party vendor. So here we have a very simple example. We have this fetch user function that we define, calling out to an endpoint. We have this type user that we defined, and we're telling TypeScript this is what this endpoint is going to return. We have the response object in the middle here, and on the right-hand side, we have the screen. We're rendering out the zip code. Pretty simple. But then what happens if the API changes? Before we were seeing that zip was included in address property, but now it's in location. TypeScript is fine. It says it's all good, because we're telling TypeScript this is what's going to happen, and it believes us. But we know that when we go to render it, we're going to get a crash. So how do we prevent this? I'm going to go over some good, better, and best practices on how to handle data validation. So let's start with validating data inside of your app. There's a lot of different libraries you can use for data validation. For this example, I chose Zod. So here we have this user schema object, which is just defining the structure of the data that you're expecting. We have address, as you can see, which is an object. And inside there, what we're caring about is zip code. And then on the right-hand side here, we see that we're using this user schema. We're calling safe parse and passing in data that's been returned from our endpoint. So what's happening inside safe parse is it's taking that data, comparing it to the schema that we created, and making sure that it matches. We see here if result.success is true, we have access to a data property. Otherwise, we have an error object. And we could see that within this error object, we have some helpful messaging. We have this path property, which shows address and a message of required. Because in that example, remember, address got switched to location. Awesome. We now know with absolute certainty that if result.success is true, the data is in the format we expect. We have no chance of unexpected behavior working with this data. But what if the API changes? The app not crashing is great, but just perpetually showing an error screen to the user isn't a good experience either. We could release an app update to update this one singular property, but it seems kind of like overkill, and app review processes could take a long time. So we're going to look at a better way to do this. Validation on the back end. You can see that we're doing the same thing with this user schema from the previous slide, but we're handling it on the back end. Now we can react to schema errors in a much better way, being able to identify and fix the cause of the issue without having to touch the mobile app. Our mobile app will show an error message while the endpoint is returning an error, and then once we fix it, it'll show the data as expected. So now we know for certain that when we call this endpoint on our back end, the data is in the structure that we expect. There's just one last problem to solve. There's still a human element involved in this. Developers now have to copy types between the front end and the back end. And occasionally, you could copy the type incorrectly. You could be meaning to copy the result of get payment summary instead of get payment summary. So then when you bring in get payment summary, you're including a property that doesn't exist on there. You use that property in your screen, and then it crashes. And if it sounds like a little bit too specific of an example, it's because it is. And you're looking at the culprit. So the best solution that we have for this is sharing types across the stack. We're doing exactly what we did on the previous slide, but we have an internal NPM package that we publish with the API and consume inside the mobile app. We have this get user response up here that we are using within the fetch user function. And then on the right-hand side here in the mobile app, we see that we're importing from this Clearcover mobile app types NPM package. Now, whenever a type is changed on the back end, it gets updated within the NPM package, and the front end has the most up-to-date version of the response structure. This guarantee of data is an amazing feeling. We know for certain that when we're dealing with data inside of our app, regardless of its origin, we know its structure. Now, I know that not all backends are running on TypeScript, so here's a list of different libraries you could use for validation. For TypeScript, there's Zod, which was showcased here, IOTS, which is very similar but more of a functional programming approach that we use at Clearcover. But then here I have something for Java and Kotlin, this TypeScript generator library that we use at Clearcover because we have a lot of microservices in Kotlin. And with this, you're able to use this library to take your Java or Kotlin classes and build TypeScript types off of them instantly. And then you're just able to export those within your NPM package. And then there's something similar for Ruby, where you could use create types from serializers. So just because your backend isn't in TypeScript doesn't mean that you can't leverage sharing these types across the stack. And the data consistency is one of the most amazing things that we've built at Clearcover, and it makes our experience so much better. OK, 2 challenges down, 1 to go. The last issue specific to React Native deals with how many open source libraries a lot of our apps are using. To be clear, the abundance of open source libraries is one of React Native's greatest strengths. Having access to so many well-maintained libraries for all sorts of different functionality makes developing apps that much better. And we use a lot of amazing libraries at Clearcover, such as React Navigation, React Native Vision Camera, React Native Maps, and many more. But every time you introduce a new library to your project, you're adding a new dependency that has code that you don't know about. So let's solve that. For our final section, I'm going to go over how we can use tooling to monitor and manage our projects. Today we're going to be looking at Sentry, performance monitoring tool that we use at Clearcover. Just so you know, this is not a paid advertisement, but it was awesome to see Sentry present, and I'm hoping I could get some cooler swag since you're in my presentation. At Clearcover, we use Sentry in 2 different but equally important ways: automatic crash detection and identifying non-fatal errors. So here I have an example of a JavaScript crash that was caught in our app a while back. Sentry is able to show you the exact line that it crashed, allowing us to investigate what caused the error to be thrown. In our case, we were using dateFNS, and it turns out that the isWithinInterval function we used threw an exception if the start time was after the end time. Once we learned this, we were able to go into our code, add a guard against this, and fix the problem, so no further users encountered it. Sentry also also logs native level crashes for you. And here's one that Sentry caught for us. This was a crash caused by a library that downloads files and saves them locally. Thanks to Sentry showing us the exception cause, we were able to investigate the error in the library, found other users experiencing the same issue, and then found some solutions alongside the community. Now, I want to shift our focus to a stability issue that isn't crashing. Soft locks, or areas of the app where your app doesn't crash, but the user's prevented from being able to do anything. Here we have an implementation of the awesome React Native Vision camera library where we're trying to render a camera view. And thanks to TypeScript, we know that we need to check that the device isn't null to be able to mount the camera component. So let's fix that. Awesome. No crashing. But this isn't a good user experience. Sure, the app isn't crashing, but the user's not able to do anything. And perhaps more importantly, we as developers aren't able to do anything because we don't know when or why users are getting into this state. With Sentry, we can capture a message to let us know when we're in a spot that we don't want to be. And when we capture that message, we get a ton of data for free. We're able to see what OS a user is on, what their operating system is, what version of React Native they're running, what brand of phone they're using, which is really useful for Android considering differences between Google and Samsung phones, and a whole lot more information about the user. This gives us a ton to work with so that we can more effectively debug these issues. And what's even better is that you could include additional data that could help you debug issues. Here's a snippet that we use at Clearcover as part of our video recording flow. At a high level, you can see that if there's a recording error and it's not due to the user canceling the recording themselves, we want to log it in Sentry. And you can also see that we're including a bunch of different information inside of the log that we can use to more effectively debug the issue. And for a real-world application of how beneficial it is to use performance monitoring tools, if we take a look at this error.code that we're checking, there are 64 possible values. Of course, it's our responsibility as developers to test our features as best as we can. But we also have to be realistic. Setting up scenarios for 64 different recording errors just isn't feasible. So we can leverage these tools to help us understand when and why users are getting stuck in these areas so we could fix them and prevent them from happening in the future. So, in conclusion, using TypeScript not only improves the stability of your app, but the overall developer experience. Using libraries to validate data and then sharing those types across the front end and the back end guarantees consistency and stability. And finally, using error monitoring tools allows you to stay on top of crashes and soft locks, allowing you to react to them quickly with all the information you need. I hope you can use some of these tips to make your app the most stable and the best it could be. Thank you so much for your time and energy.